Hi, okay, now I want to continue the FET DC analysis for the voltage divider configuration. Now we want to find IDQ and VGSQ using graphical method. So for this method, we need to draw the curve. So remember that this curve, is generated using this table. Okay, we find values in this table, okay, by using this formula. And actually this formula is come out from the Shockley equation. Remember the Shockley equation? So Shockley equation is ID equal to IDSS 1 minus VGS over VP and squared. So when we insert VGS here, VGS equal to 0, so the answer we get ID equal to IDSS. When we insert VGS here equal to 0.3 VP, so we get this value, and the rest, okay, following the formula. Then you just calculate, okay, this value, so you get negative 0.9, negative 1.5, and negative 3 for the VGS. IDSS you get 6, this one is 3 milli, and this is 1.5, and final is 0 milliampere. And then you get 4 points, okay, so you get 1 point, second, 1, 2, 3, 4, somewhere around here. Okay, however, for the DMOSFET, we know that the current ID, the ID current, always greater than the IDSS. Here is the IDSS. So it has extra current, not extra current, the current actually is increasing. So this table only produce a curve from this part only. So we need to find another point for the for the current increase at the enhancement mode. So we call this is the enhancement mode. This is the depletion mode. Okay, we know that the DMOSFET will operate in 2 modes, right? So for the extra plot point, when VGS is a positive, it means that VGS is positive somewhere around here. We take VGS equal to 1 positive due to negative 3 VP, and when VGS is positive, it rises more rapidly. So we get this point here, okay, and this value. Okay, so using Shockley equation for VGS equal to 1, the ID is 10.67 milliampere. Okay, so this is the value we get, VGS 1 and ID equal to 10.67 milliampere. So if you want to draw a transfer curve for DMOSFET, you must get current ID when VGS is positive. It shows that this is a DMOSFET that has ID more than IDSS. Okay, next. Okay, we go for the circuit equation, which is VGS, and again this equation is get from the circuit, okay, where the equation is actually general equation is VGS VG minus ID at S, and referring to the circuit from the previous question, so RS is 750 ohm. Okay, then this equation, this is a linear equation, and you can get linear line which is like this. Okay, So take 2 point for plotting the point. Okay, so you just insert 0. If VGS is 0 and ID you calculate, you get 2 here. And if ID here is 0, VGS equal to 1.5. So this point is from this equation. So after you get these 2 points, then you plot on the graph and you get, this is the first point, okay, which is 0. Okay, sorry, the second point, this is 1.5 and 0, and this another one is 0 and 2. Okay, this is these 2 point, then you make a straight line from here, then you get this line. Okay, after that find the line that intersects with the overlapping on the curve, so this one, so we call it the Q point. Okay, and then we get what is the IDQ and VGSQ we get from the graph. So the Q point is actually at ID equal to 3.1 milliampere, which is very close to the value of ID that we obtained by using mathematical approach, and all other value can be obtained after obtaining the value of ID. This means that, okay, for this part we only calculate to get IDQ. Now this is the IDQ that we get, and also VGSQ. Okay, the rest, if the question asks you to get VDS, VD, VS, okay, we use this value to calculate the rest. Okay, now for this there is another, this one is not example, I give you question. I want you to do this the same question, but replace the RS, okay, with 150 ohm, and use mathematical and also graphical method. Okay, so I give here the answer. Okay, I need your step-by-step calculation. Please upload your work in class note, and by this week, so next week we can discuss during class.